All right. In today's video, we're going to be talking about 6.7a, generate equivalent numerical expressions using order of operations, including whole numbers, exponents, and prime factorizations. On this particular video, we're going to be focusing on prime factorization. So the first word, prime, let's talk about that first. Okay, so there are three types of numbers: unit numbers, 1, prime, and composite. All right, so what's the difference between the three? Well, obviously, unit is 1. In 6th grade math, you're going to hear like unit rate a lot. So unit rate, just again, the rate for one thing. Prime, well, let's talk about composite actually. Composite is when a number has more than 2 factors. So for example, 16 would have factors of 1, 16, 2, and 8, and 4. Of course, I don't need to list 4 twice because 4 times 4 is 16. So 1 times 16 is 16, 2 times 8 is 16, and 4 times 4 is 16, or 4 squared is 16. So prime would mean it would only have 2 factors, 1 and itself. So 2 is prime, because the only whole numbers I can multiply to get to 2 is 1 and 2. Another example would be 17. The only numbers I can multiply to get to 17 are 1 and 17. Of course, I'm sure you're saying, couldn't you multiply 2 times 8.5? But again, they have to be whole numbers. So again, prime is when it only has 2 factors, 1 and itself. Okay. So let's look at this question. Question 12 from the 2018 test, with which expression is equivalent to 16 plus 2 times 36? So what they're asking us to do is to break down this expression into its prime factorization. So, and we will, knowing the order of operation, is going to help us with this. First, let's do 16. Now, prime factorization, you guys remember the factor tree. I want to teach a different method if you haven't been exposed to it already. So upside down division. What that is I like this. Factor trees are cool. I'll do both. But upside down division is an organized way to find the prime factors of a number. So let's start with 16. The smallest prime number, the only prime number that will go into 16 is 2. So then I'm going to divide 16 by 2, and I'm going to get 8. I'm going to put it right here. Another box. Prime number that will go into 8 is 2. 8 divided by 2 is 4. Do it again. What prime number will go to 4? It's 2. And 4 divided by 2 is 2. And then when I get to the bottom, when I have a prime number, that means I'm done. So 16 would be 2 times 2 times 2 times 2, which is 2 to the 4th. So right now, I know it can't be G or J. All right, so then plus, I'm going to erase this. And let's do 2 times 36. Let's focus on the 36. This one I'm going to mix it up. I'm going to do a factor tree. 2, 18, 2, 9. Oh, wrong. Sorry. And 3, and 3. So the prime factorization of 36 is 2 squared times 3 squared. Why? Because I have 2 2's and 2 3's. Excuse me. But I also have, put it in green, I also have this 2 right here that we can't forget about. So then I'm going to have 2 to the 3rd power times 3 squared, because again I had 2 squared, I have one more, and then one more 2 would be 2 times 2 times 2, and that's 2 to the 3rd power. So my answer should be 2 to the 4th power plus 2 to the 3rd power times 3 to the 2nd power. So based on this, my answer obviously is F. The reason it can't be H is because they forgot about this 2 right here. All right. So again, on this problem, all they wanted me to do, or us to do, is to break it down prime factorization, and I showed you 2 different methods, which we're going to go over again, upside down division or the factor tree. If All right, so from the 2017 test, Leon wrote an expression that is equivalent to 30 plus 6 divided by 12. Which expression could be one Leon wrote? Okay, so order of operations, I know I would have to add this first, and then divide by 12. So 36 divided by 12 is 3. Let's see if we can get 3 on any other problems. So the first one, 36 divided by 3 times 4. I have to do it from left to right, so 36 divided by 3 is 12, and 12 times 4 is 48. Nope, all right, that's not it. Can't be that one. All right, let's cross out A. All right, let's try check B. 3 times 3 is 9, times 4 is 36. It's in parentheses, I have to do that first. Then I divide, 36 divided by 4 is 9. 9 times 3 is 27. Nope, that's not 3. All right, can't be that one. Can't be B. All right. Well, let's look at this one. C, 5 times 6 is 30. Okay, so 30 plus 2 times 3, which is 6, divided by 3 times 2 times 2. All right, next I'm going to do this. 6 divided by 3 is 2, and then 2 times 2 times 2, which is 8, and 30 plus 8 is not 3. All right, nope, can't be C. All right, let's hope it's D, or I'm doing this all wrong. All right, so here we go. We're going to do the parentheses first. 3 times 3 is 9, times 2 is 18, times 2 is 36. I have a division, but I also have another parentheses, so I have to do that next. The other parentheses is 3 times 2, which is 6, times 2, which is 12, and 36 divided by 12 is 3. So that is our answer. This one, it's similar to prime factorization. They broke down 36, they broke down 12 into its prime factorization, but this also obviously combined the order of operations. So again, on this problem, knowing the rules of PEMDAS, order of operations, and knowing prime factorization helped us figure this out, and it was D. All right, here we go. 90. Mr. Gonzalez showed students part of the prime factorization of 90. One factor is missing. What number completes this prime factorization? All right, so I'm not even going to pay attention to this. Let's just go ahead and do the prime factorization of 90, and I'm going to start down here. So 90, I'm going to do upside down division. 2 is the smallest number, because again, if it's even, 2 is always the smallest prime number that's going to go into it. 90 divided by 2 is 45. Now 2 won't go into this, but the next small prime number is 3. 3 will go into that. 15 times, 3 will go into that, and 5. So, and that completes it, because when I'm at the bottom and I have a prime number, I am done. So my prime factorization is 2 squared times, nope, just kidding, my bad, 2 to the power of 1, or just 2, times 3 squared, or 3 to the power of 2, times 5, or 5 to the power of 1. I don't have to put that 1, but I did. Okay, so looking at the missing blank, what am I missing? Well, they have the 2, they have the 3 squared, but they don't have the 5. So if I were bubbling it in, make sure if that were my decimal, I would bubble it here, bubble 5 down there, and then obviously a positive 5. So be careful with place value, and you only have to, if you were bubbling it in, you only have to bubble in negative. You don't have to bubble in positive, but it's always a good practice just to go ahead and bubble that in too. So I'm going to go ahead and show you 90 prime factorization with the factor tree, 2 and 45. Let's just do it a little different, 9 and 5 and 3 and 3. Again, 1, 2, which is here, 2 3s, which is there, and we're missing the 5. So either way, we got 5. All right. Our last problem, what is the prime factorization of 110? And again, we're going to do it 2 ways. 110, 2 will go into it. 110 divided by 2 is 55. Okay, 2 won't go into this, obviously, so it's 5. 5 will go into that 11 times. And then I'm done. Pretty simple, pretty easy. Let's check it, make sure we got it right. 2 times 5 is 10. 10 times 11 is 110. That's our answer. If we did the factor tree, we'll do 11 and 10 and 2 and 5. And you still get the same answer. All right. Well, that concludes this video on using order of operation and prime factorization. I hope this has made sense. If you have any additional questions or concerns, you can email me at jhewlett@leisd.ws. Thanks, and have a great day.